we've been doing and what's there currently, as well as a little bit of a workshop session. So yeah, let's get started. Who am I? I am Cameron. I've been over at Armory for about 1.5 years, maybe a little bit more at this point. I've been contributing to Spinnaker that whole time, so that's been pretty cool. It's my first time working in open source, and I have the fortunate, I don't know, happenstance to be one of the co-leads for the Spinnaker platform SIG. Here's some of my contact information. Please feel free to reach out if you have questions, comments, concerns, feedback, whatever. Cool, so our agenda for today, we're gonna go over plugin concepts. And I don't know if anyone's attended the last Spinnaker Summit plugin session. We're gonna be going over some of the same stuff we went over last time, as well as some stuff that's changed. So there's been some updates to the plugin framework and some of the extension points, and it's pretty exciting. So we're gonna go over some plugin concepts, ways of extending Spinnaker with the plugin framework. There are multiple ways of extending Spinnaker, but today we're focusing on the plugin framework. We'll talk about backend development, a little bit about front-end development. That's not my specialty, so I'm gonna probably gloss over a little bit stuff there. Talking about building the plugin, as well as deploying and delivering your plugin. For the workshop part of this, we'll be adding a plugin to your existing Spinnaker installation. So again, the idea here is you've got Spinnaker up and running. We're going to add a plugin to it. The idea here is that you're running Spinnaker 1.21, and we'll add a plugin and see it on the UI. So we're going to be adding the random wait stage plugin to Spinnaker today. So that's going to be the first step. So each step is going to be a little bit iterative. So the second part is we'll clone a plugin repo. That same repository that the same plugin we're adding to our Spinnaker installation, we're going to be adding that, just cloning that repo and then building it and doing the whole release process on our local host. So that'll be cool. We'll see kind of how the build system works. Then we'll add that release bundle is what we call it, the plugin bundle. We'll add that to Orca in IntelliJ, and we'll show you guys how to debug into your plugin code itself. Once you can do that, that's a really good foothold for iterating on plugins, right, or on a piece of code. We'll also show you how to write some tests for that as well. Or rather, we'll go over the tests that are in the PF4J stage plugin and show you how they work. Then finally, we're going to be connecting, we're going to put all of it together, and we're going to use telepresence to connect our Orca that is running locally with our plugin and debug into our plugin while connecting to running Spinnaker installation. Does that all make sense to everyone? Any questions? Does that sound like a good plan for today? Awesome, sweet. Concepts. So let's go over some concepts here. I'm going to click into some of these links because they are important. So PF4J is the plugin framework that we've added to Spinnaker. We've taken PF4J and we've basically customized it for some of our own usage. So PF4J has a lot of niceties that come with it, such as like isolated class path loading, and it has a really nice update system as well. We've what's the word? We've extended parts of it and customized it a bit more for Spinnaker itself. So the concept of a plugin manager, well, we have a Spinnaker plugin manager and a Spinnaker plugin loader, etc. There's this concept of extension points, and we're going to be talking about that a little bit later today. It might be coming up next, in fact. In fact, it is coming up next. So let's talk about extension points. So extension points are ways of hooking in to Spinnaker itself. So we're talking about plugins. What does that mean, right? There's a bunch of Spinnaker microservices, and adding functionality to them happens in a few different ways. The tried and true method that we're promoting right now is the idea of an extension point. So an extension point is a pretty solid contract within the code. And I say pretty solid right now, we're working on making it quite a bit more solid in the future. There's a RFC out right now that is going over versioning updates for Spinnaker as a whole. And once that has been finalized, we'll have a lot stronger guarantees that, hey, this plugin works on this extension point for this version. So let's take a look at what one of these extension points is. This is it. So it's essentially an interface. In fact, this one is just an interface. It's not even using the extension point anymore, which is interesting. Oh, it's an old. Oh, it's been moved. Sorry. So this is one of the reasons why we're going for a more solid versioning scheme, is because sometimes the packages do move around. The plugin system is in its early stages, but it is getting more mature over time. So you can see the simple stage interface. It just extends this Spinnaker extension point. What that means is you can write a plugin against this contract where you define the execute method as well as the get name method. And by doing those two things, yeah, you do have to implement, the input, output, status, and surrounding auxiliary classes. But by implementing those two methods, you're off to the races with adding functionality to Spinnaker. Simple stage is quite literally just that. It is a stage that you can add to Spinnaker, and it's pretty dumb. It does execute, right? So extension points are, just backing up again, are like the tried and true solid contracts that we have in the code base. There's a few different ways of extending Spinnaker now. So we'll go over those methods in the next section. Going back to extension points, something has to use extension points, right? So that's what extensions are. So let's take a look at what an extension is. This is the example plugin that we're going to be using today. It's all over the Spinnaker documentation. And I think it's just a good, simple plugin to kind of wrap your head around. It's a random wait stage. And all it does is, given a max wait time, it will wait a random number of seconds when it runs. So there's a wait stage in Spinnaker that you can configure it to wait 30 seconds or whatever you want. This will then now wait a random number of seconds. So as you can see, it's a class. This is in Kotlin, by the way, so it might look a little bit different than you're used to. So it's a class, takes in a configuration, and it extends, or rather implements the simple stage. So you pass an input to it, and that is how you can get the max wait time here. So all we're doing here is we're overriding those two methods that I showed earlier. It's the get name method as well as the execute method. There's a little bit of, what's the term? I don't want to say accounting, but maybe accounting is the right term, like putting your ducks in order, setting the context and output so that you're updating the pipeline execution as Spinnaker is, as a pipeline is executing. So this is an example of an extension here. And do note you have to add the add extension tag. Cool, moving on. So an extension, there's a question I see, is Kotlin the preferred language for plugins? It's not, but we've been doing a lot of our plugins in Kotlin. We do have a mix though, depending on the developer and their level of interest really in Kotlin. I think more Kotlin code is being added to the code base, and a good amount of the plugin framework code itself in Cork, which is the shared library amongst all services, is written in Kotlin. So we talked about an extension point, and an extension point, like we saw, can be something like simple stage. Great. Here's an example of using that extension in this class. Now, what if you want to utilize multiple extensions? Well, that's really where this idea of a plugin comes in. So every plugin can have one or more extension points used in it. You can also do 0 extension points, and we'll talk about that in the next section. So as you see here, this is the random wait stage plugin. We call it PF4J, but that was just an early naming choice. But yeah, so this plugin itself takes advantage of one extension point within Orca, and then it has a deck component as well. Because deck is on a different tech stack, it has a different way of adding additional functionality to deck. And deck is written in a mix of Angular and React. The plugin framework is mostly on React though. Cool. Any questions so far?
Has anyone
Sorry?
I was going to ask, has anyone here used Kotlin before or has seen Kotlin before? Just wanted to make sure no one's intimidated, because Kotlin, I didn't never use Kotlin before I joined Armory, and you can use it interchangeably with Java. So if you have any Java experience, it's pretty easy to pick up. You can mix in Kotlin classes and Java classes. It doesn't have to be any Kotlin at all if you prefer to not write any. But it's pretty easy to pick up. Like I said, it feels like a less wordy flavor of Java. You have to type less, which is nice.
Yeah, that's so true. So a good example of that is the random wait config. This is the whole class. It's just a config class, and it has one variable there. You don't have to define, oh, it's private, it's blah blah blah. You just define it right here, and you're off to the races. It's a lot less boilerplate you have to end up writing. Cool. So as we go on, I guess one more thing to note here too, as you see in this plugin, a plugin can span multiple services. So there is a little bit of implementation detail bleeding here. So you do kind of have to know, what is it, Spinnaker architecture? Yeah. So you do have to know a little bit about Spinnaker architecture and what the different services do to kind of have a good understanding of what extension points you would like to take advantage of. And we can go over that later as needed. So cool. So plugin developers, that's all of us here. That's what we're here for, right? Is making plugins and adding extra functionality. So there's the idea of a Spinnaker operator and a Spinnaker user. So let's go into kind of what these two personas are and how they're different. So a Spinnaker operator is someone who is usually on like a central DevOps team, and they're the ones who actually run Spinnaker. They're the ones who will probably be adding plugins for their users to consume. Also to make their own lives easier, help with auditing, whatever. The world is your oyster here. So Spinnaker operators are generally not developers. They're generally people who are used to DevOps, probably like Python, Golang, Bash, and YAML, right? And that's what they know. So part of the reason some choices that we've made over time have kind of been to help reduce the barrier of entry for adding plugins to Spinnaker. So hopefully that has, hopefully we've made it easier rather than harder. Spinnaker users, on the other hand, are usually app developers. They're people who are going in and running a pipeline. They're looking at, hey, what happened? Why did my service die? And they're also happy that their service rolled back, because that's what Spinnaker helps with. Cool. So let's go on to extending Spinnaker. As we talked about, there's a few different types of ways of extending Spinnaker. So we have 3 different examples here that let's check them out. So we've looked at this example, and we'll continue to look at this example, the PF4J stage plugin. We kind of already looked at it, so I don't want to go too deep into it again. Excuse me, but it has that extension point that that's in the Orca package. So that's essentially how it gets wired up. Spinnaker starts up. PF4J says, hey, I've got these extensions, these plugins local to me. Here's all the extensions, and it adds them to their own isolated class paths. Why is isolated class path important? Essentially, it helps your plugins not trample each other based on their dependencies. Cool. So those are extension points, and so far those have been the paved road. That has been the easiest way of adding functionality to Spinnaker. The second method here is actually extremely similar, and it's interface based. So there's been an update to PF4J that allows any interface to be used by PF4J. So you can write a plugin that takes advantage of any interface within Spinnaker, provided it's public and all that fun stuff. And then you can just hook into it and have the same protections that you do with extension points. So for this in particular, this is adding, I believe, another secret engine. So in Cork, there's an interface called Secret Engine, and it's a way of adding secrets to your configs in a secure way. So this is just a silly, let's say, implementation of it, where it just, I think you just enter a password and that sets your password there, right? So it's not that good of a secret manager. That being said, this is in a Commons package that is then included in both Orca and CloudDriver, and now Orca and CloudDriver have access to this new secret engine. So this kind of came up while we were developing the plugin framework. So there's we kind of talk about them slightly differently, but they're very related, let's say. Finally, the third way of extending Spinnaker with the plugin framework is using this by doing Spring plugins, is what we call them. So this has been we have been encouraging people to not do Spring plugins, because you're essentially you're tied to implementation details. So if there's something that there's some functionality that you want to modify that does not have an interface and does not have an extension point, but you still want to kind of go in and modify things, we have this method of doing that. And again, that's a Spring plugin. So let's take a look at what that looks like. Cool. So this, well, actually, let's go back to the Kotlin portion of it. So in this, we're going to look at the plugin class here. And you can see in this case, we're inheriting from this privileged Spring plugin. That gives us a method, register bean definitions, and so far, this has kind of been a little bit of a, not the best developer experience with Spring plugins. Uh, who here does Spring development? Are there people who develop in Spring here? Thumbs up, thumbs down. Yes, no, yes, yeah, Fernando, sweet. So with this, and I'm going to say it now, it's actually the old method of extending Spinnaker with Spring. You did not have access to Spring Boot annotations. You had to call functions that we wrote ourselves to add beans to the higher level application context. And then you'd have to like call register bean. So this was a very kind of, you're tied to implementation details. There's no contracts in place here. The code can change out underneath you. That was true like 2 weeks ago. And then recently, Clay has, Clay right here actually, he has been updating Spinnaker, the plugin framework. He added a Spring plugin loader, and now you can actually use all the Spring annotations you want within your plugin. And you don't have to do this weird method of calling these, you know, homegrown functions to register your classes. It makes development a lot simpler and more friendly for Spring Boot developers. So we do need to update our plugins as that code's merged. I don't believe it's merged yet, so I would still recommend using interfaces or extension points.
It was just merged.
Oh, it was
like
just merged
today.
Okay. But there's no, I guess there's no like release out with it. But look for that in the future, and that's going to be it's going to be a really nice way, I think, of actually extending Spinnaker. So why would I say it's a really nice way when you're kind of based on implementation details? That sounds like not much fun and a lot of maintenance. Well, we've been talking and are moving towards these API packages. So within each project, we're creating these service-API modules. And what these modules are, essentially, these are our contracts. So the code within these modules, the idea is they're going to be long-term stable, and we're planning on doing semver here, and a meaningful semver. So like breaking changes are actually caught as breaking changes. So again, that's all part of this RFC that's out right now. You can check it out in the Spin governance repo, proposal for a consolidated build system. So this is an effort by Google and talking about how we can clean up our versioning and our build woes. So I'm very much looking forward to how the project progresses. And I think while in the past Spring-based plugins have been not encouraged, I think in the future, you know, it might be kind of a nice way of doing development. Any questions so far? Feel free to always just raise your hand or post in chat. Just gonna keep on going though. So let's talk a little bit about backend development. So within the backend development, let's just take a quick look at the simple stage again. So this again is within Orca. It's in the Orca API package. So it is a more long-term stable package is the idea. With simple stage in particular, we are planning on deprecating it or moving it at some point. The reason being is because we have added an even better extension point. So part of the purpose of having a plugin system in the first place is twofold. We want to move Spinnaker towards a lean core and an expansive ecosystem. So far, we've been focused on the expansive ecosystem aspect of it. We've been adding extension points so that we can add new features and new custom stages, new notification types, etc. We would also like to move towards a lean core. And what does that mean? Within Orca, there are a lot of stages. In particular, there is a Gremlin stage. And Gremlin is a pretty cool company that does chaos engineering. But they are also a private company. And to me, it feels weird that this is within the code base. And in fact, if you're not a Gremlin user, you have Gremlin code running within Orca. So that just doesn't feel very good, right? If there's a CVE here, you're not even using it, and you might have a CVE on your hands, right? Some places might care about that more than others. That's up to you and your security team to determine. Why is this important? So there's this stage definition builder, and this is the basis of all stages. So every stage in Spinnaker implements the stage definition builder. So what we've done is we've moved the stage definition builder to the Orca API package. So it's down here in pipeline graph. So here is stage definition builder. And now every stage within Spinnaker, it actually uses the Orca API package. One thing to note as well is as we move packages to the Orca API, because your plugin depends on them, we try to reduce the number of dependencies brought over as much as possible. So this stage definition builder, now that it's in the Orca API package, something like the Gremlin stage, this would be a perfect plugin, which I believe, Brian, you're actually working on that, I think, as an example, right?
Yep, that's correct. I am getting through it slowly. I mean, I've honestly have no front-end experience previously, so for me, the deck part's the hardest, but the Orca part is pretty straightforward.
Nice, perfect. Yeah, so once there's that plugin comes out, we'll be able to essentially rip this out of the code base and come up with a deprecation strategy, of course. So stages are one aspect, but there's many pieces or many parts of the code base where there's just a lot of implementation details, let's say. Oh, you want CI? Well, there's all these different CI tools, and you have to have the code for all of them in order to utilize any. We'd like to change that. Right. Let's take another look at this random weight plugin and kind of talk about some of the surrounding classes. So every plugin, regardless of if you're a extension point based plugin, a Spring based plugin, etc., you have to define a plugin class. So you can define a start and stop method, and this is what we're going to be using to debug into today. We'll just put a debug at line 20, for instance. We talked a little bit about the random weight stage itself. It takes in this configuration class, which, as you saw earlier, it was just a single max wait time variable. There's also this random weight input, and that is actually pretty closely tied to the front end code here. So if we take a look at random weight input, it has a max wait time. So what that means is this stage expects a max wait time as part of the stage definition. So the front end needs to send the max wait time variable with some integer value in order for the stage to work. Cool. Let's see, config, context and output are pretty similar. As this is a pretty simple stage, there's only one task really, and we hide that fact from you. So when you're developing stages, there's this, they have multiple tasks. The context is meant to share data between those tasks. The output is essentially what you want to return back to the pipeline execution. And in this case, we're saying this is the time we actually waited. Right, I think we took a look at the input, the config. As you see, it's all very similar, right? The config is pretty important though. So let's talk about this a sec. This is actually deprecated. It's now plugin configuration. And then you need to specify a name. So this name is important because you use it to configure your plugin. So the plugin configurations, and we're going to get there pretty soon. This is what they'll look like on a running, like an Orca, for instance. You have a top-level key of Spinnaker. That was done for kind of future-proofing reasons. And then under the extensibility and plugins key. So we've defined our plugin here, Armory random weight plugin, and we've defined what extensions we have configured. We configure what extensions we've defined, maybe is the better way of saying that. So we say, cool, this plugin's enabled, this extension in particular is enabled, and for this extension, what are the configs for it? Well, we've got this default max wait time. How's everyone doing? Is this interesting, useful, exciting, all of the above? Yeah, cool, sweet. All right, let's keep on keeping on and get to the workshop part. Sweet. So let's see. This is let's talk about debugging a little bit. Yeah. So debugging is pretty important. We will be doing this as part of the workshop today. So I don't want to go too deep into this. We will run a command called release bundle, and it'll generate this this ref file that we'll use in order to do our debugging. So there is a lot of thought that is going into how can we lower the barrier of entry to do plugin development, because it's not the easiest thing. And I appreciate that everyone here is here and willing and able to make plugins. We're looking to lower that barrier and make your lives easier over time. So front-end development. So with front-end development, it's React TypeScript based. So we have a rollup config and a package.json. Those are pretty boring to look at, in my opinion. Let's just take a look at them real quick. Our package.json has got our packages, right? Our rollup config, it just says, here's your stage that you're doing. And this is an important thing, I believe, to have your Spinnaker shared libraries, so that you don't have to pull in your own React and everything. And then let's take a look at the index, random wait stage rather. So cool. So here's our random wait stage, and as you see, we've defined a few different things here, right? So we've got a stage configuration. We've got some details. So this will pop up when you're running your pipeline and you hover over the stage. And then you have your, what does your stage look like on the front end in the configuration part of the code, of the pipeline editing, yeah. So when you go to edit a pipeline, what does that look like? And this is what you see here. Let's see. Another point I'd like to point out. No, I forgot what I was going to say. Let's go on to building our plugin. So take a look at the project structure. It's just going to take us back to P4J, again, our favorite example plugin. So each of these folders are named in an important way, I guess. So the folders are named, they need to include the services that they're going to be laid down on. So for instance, the deck package will be, when we create a bundle, when we do the build, each of these packages will have their own zip file. So essentially our plugin bundle is a zip of zips. Sounds kind of familiar. And that's how what we use to distribute. So each of these will turn into a zip that we will use. Yeah, let's take a look at our build.gradle. Not super interesting here. Maybe let's take a look at the Orca build Gradle. As you see, we have this requires field here. This is what I was referring to earlier with the versioning of Spinnaker. So right now, we set the requires to 000 because the Spinnaker version that you have access to is lacking the rigidity, confidence. It's not actually Semver for what we want it for. That's why we are moving towards a better versioning scheme. You don't have to pull in a ton of stuff with Spinnaker plugins. Hopefully most of that is just unnecessary. Take a look at properties. It would be good if we had a better way of pushing out updates to like what the P4J version should be, et cetera, et cetera. But yeah. We do have some pretty good actions set up here with our project. So if you guys are in GitHub, we have a few different actions set up where whenever there's a new Quark release or a new Orca release, we will pull that version in and then test it out and see, hey, does it build, does it work, do the tests pass? As you can see, the latest Quark broke this plugin. So that means we now need to go in and fix something in order for it to work. When we do that, we'll create a new release. And what this action does is builds the project, creates a release here in the releases tab, as well as updates plugin repository. And we're going to get there like next. So maybe we'll just go there now. Cool. So you have a new version of your plugin. How do you release it? Well, there's a, sorry? No. So there's a P4J project called P4J Update that we utilize in order to deliver plugins. So if you check out the organization, Spinnaker plugin examples on GitHub, these are all open source plugins. They're not super useful, at least right now. We'll probably move them to a different org as they become useful. We're still figuring all of that out. But we have this example plugin repository. So every time there's a new release, the GitHub Actions comes to this repo and updates the plugin repository. So let's take a look at what that looks like. This is essentially a plugin repository. So when you're a Spinnaker operator and you want to add a plugin to your Spinnaker installation, this is what is the source of truth for that. So for every release of a plugin, it will add a new release to the plugin's release list, right? So it, as you see here, it's our random weight plugin. And By the way, this ID is the ID used in your configuration. A little description of provider, so either the Git repo or email, for instance, and then a list of releases. So the releases here have the version of the plugin, which is how you refer to a specific version, the date it was done, the requires field. So for this plugin, once this works better, and you can see it kind of was working, but then the contracts aren't super strong there. Once this is working, we'll be able to have better constraints here to say, hey, actually there was a breaking change in Orca 234, so you need to have greater than 244 or something, right? It has the checksum and as well as the URL of the plugin, where the zip of zips is located at. So again, we've got actions that help us out with all of these. So if you just take a look at this PF4J stage plugin in the workflows and take a look at the release, it has all that fun stuff here. Has anyone used GitHub Actions before? Yeah. It's pretty cool. It's not like the easiest, but it also like it's getting better over time, I feel. So cool. So that's the plugin repository. So how do you access this? How does Spinnaker know what the heck this is? Configuration, YAML, yay. So essentially in your Spinnaker services, this is the final or close to the final result of what's laid down as the plugin, the plugin configurations. So we configure a repository, and that's separate from configuring the plugins themselves. You're able to configure multiple repositories here, and they'll go in order until it finds the plugin and version combo you have specified. If you don't specify a version, it grabs the latest. In our case here, we have a repository that's pointing to this repositories.json. So you can point to either repositories.json or a plugins.json file. Repositories.json is essentially duplicating what we have here. However, you can have multiple repositories defined within this repositories.json. So it's you can kind of create a tree structure where you have a lot of different plugin repositories and that point to different plugin.json files. So there's not a, let's say, an agreed upon plan yet on how we're going to take plugins and add them to the open source project, or have them be available in a open source repository. We have had a bunch of talks, and I think we have a general direction we want to go. But that's something that we'd love to hear ideas if you guys have any on that. Cool. So those configurations, how are those discovered? We'll go over those pretty quickly because there's not too much talk there about there, as it is kind of also a work in progress. Right now, Halyard is doing the heavy lifting. It's going to be replaced by Cleat at some point. So we're discussing on how that's going to work. We're going to be using the operator. Backend services, what did I take here? Oh yeah, it's just sent out by PF4J update. Now, how does deck work? Because again, we talked about front end and it's a different tech stack. So this is handled slightly differently. In the past, we had a front end file that we would host separately from the bundle, and you would have to host it in a place that was okay with CORS issues and all that fun stuff, because Deck would request this resource that was stored in like an S3 bucket, excuse me. So you had to be okay with cross-site origin requests. There's been an update to this though that's been really nice. You now can configure Gate, so our API gateway, to serve plugins for the front end. This helps with CORS because you're now just requesting resources from Gate, and it's just a little bit nicer that you just talk to Gate instead of now you have to talk to some other service in another. You don't have to deal with networking problems, let's say. All right, let's move on to the workshop, the fun part. So who here has the your Spinnaker installation with from Fernando's class using the operator? I'm hoping that's most people, but if not, that's okay. I have this. I should probably move this repo actually to the Spinnaker Gardening Days repo, but this has some configs that I would like everyone to add to their Spinnaker installation, and I will show you how I'm doing that myself. So here is all of my terminal windows. Oh my goodness. Here is on the bottom left, I hope you all can see this. This is my Kubernetes cluster that Fernando set up. So I have this kubeconfig file that Fernando sent me, and I can say kube control, kubeconfig, specify my kubeconfig. I'm Cameron, so that's my namespace, get pods. Awesome. Let's look at what this operator has right now. So I have this this Orca section. So let's go, and I'm just going to remove this right now. Whoops. And please follow along as it makes sense. This is where it would be great if people had questions. You all can just shout them out, post them in chat. We're all here to help out. So I'm applying my changes. This is now making it so I'm removing a plugin from my Spinnaker installation. Just so, again, as we're all doing this hopefully together, we're all just on the same page. So let's verify what's been going on here. Echo is being taken down. Orca's being killed as well. Actually, I'm kind of surprised Echo went down, but Gate is good. So let's connect to Gate. On these top two panes here, I'm doing port forwarding. So I'm forwarding from my to my Kubernetes cluster. There was a message in chat, but private to me. Does any of the services need to be restarted after the plugins updates in the YAML file or a new version of a plugin is published? Yes, that's correct. So whenever you have an update to your configurations, you do need to apply those changes to your cluster. In particular, with plugin versions, you do need to, yes, I can add these to the slides too. You do need to update your version as well as apply those changes. We've talked with a bunch of users and Spinnaker operators, and one thing we've found has been operators want to have a version that they pin. So while we do support not specifying a version, what we've heard from the field is that people want to have, they like to specify the version that they use. So yeah, that's just, it's a control, and you get to know what's going on. So here, let me add this command here, and this is actually Q control. I've got a little, what's it called? Oh, well, that kind of sucks. Let's say namespace. Cool. And then the same for 84. And that's this one here. So what this means is now I can go to, I can go to my local host at port 9000, and bam, I'm in my Spinnaker installation. As you see here, I've got cam test is a pipeline of mine. If we look at it, I have this random wait stage defined. So I do have the stage here, but if you look here, my configuration is empty. I mean, not empty, but it doesn't look good. It's just an open box. This is as if you said, edit stage as JSON, right? This is not what we want. We want a native experience. Furthermore, when I run this code, it's not going to know what to do. There's no stage definition builder for random wait. It's not there. So let's put it there. So here's the configs I had sent out, or they're part of the workshop here. So what I'm going to do is just copy this. I'm going to come back to my operator YAML. I'm going to go to my profiles section. I'm going to say gate, delete gate, orca, delete orca. And then from the first column, I'm just going to paste because I copied this earlier and I know it's at the same indentation level. Cool. So let's just go over what these configs are here and how you might add these same configs to your installation. If you're doing the operator, this is exactly what you'd be doing. As you can see, we have very similar configs across the board here. Operator is relatively new. It uses, or it will be using Cleat. So as it's being used and improved, we're going to be improving this experience. Cool. So for Orca, this looks very familiar. We've got our Spinnaker extensibility, our plugins, we've got our random wait plugin, et cetera, et cetera. For Gate, it's similar, but slightly different. There's this key that we've added here called deck proxy. And this is telling Gate that we want you to serve to deck this plugin if it has a front-end component to it. This might be a little confusing now, but we'll get into it in a sec. So I'm just going to apply this operator again, and we can see down here in the bottom left, we see echo is updating, we see gate is updating, and orca is updating. So my gate connection here is going to be pointless actually right now. So as it's going to be cycled out. Let's just wait for that to finish up. I believe, let's see, I'll add this to the slides as well. Cool, so this is up. Let's add this port forwarding here. Now, when I go to localhost 9000, let's hope that it works as expected. This is those demo times. So let's see. Hey, check it out. That's awesome. Our random weight configuration, now rather than having a random text field here, that's kind of pointless. We have, not pointless, but you don't have very good discovery of options or native experience. Now we have a nice UI. So if we want to put this to 3 seconds, 4 seconds, let's save our changes. Go back and let's try running it now. Cool, now you can see it didn't just fail right away. In fact, it waited 1 second. So let's see what happened here. This bottom right, this link here, the source link is a pretty great link. I kind of like it. You just see what the pipeline execution object is. All right, so let's take a look. So this is our stage, our random wait stage. It succeeded. It had a max wait time, like we said, 4 seconds. And it actually, the value it got to wait was just 1 second. And that's what it waited. So if you were a downstream stage that was interested in how long your random wait stage waited for, you would be able to access this value via spell expressions. Cool. Let's move on to the next part. Does anyone have questions? Has anyone ran these commands just now and seen it work? Maybe, maybe not. I don't want to say we're running low on time, but just to ensure we don't run out of time, let's keep on going. I'm happy to help anyone though, if you guys have problems with whatever. Cool. So now let's build a plugin ourselves. So this is going to be the next step here. So let's go to Git Spinnaker plugin examples. This is the PF4J stage plugin. Yeah, I'm not going to pull anything. This was working good yesterday. Or yeah, so let's run release bundle. So what release bundle is going to do, it's going to, oh, look at that. I guess I need to update some yarn stuff. Yeah, this does happen on occasion where there's a some new, what is it, dependencies. Yarn in particular, you do have to like run the command it asks you to. That is not as expected, but that's okay for now. So let's look at the random weight Orca package, and let's look at the build directory. So there is this, and that's now. That was just generated, right? July 17, 1209, 1208, cool, 1208. So let's take a look at that. What does this look like? What is the plugin ref file, and how is it useful? So what we have here is a file that tells us where on our local host these classes live. So we've got our plugins path, we've got class dirs and libdirs. Not super interesting, not going to spend too much time on this, but this is how you build your plugin. So if we look at distributions, because this is just Orca, we've got this, we're in the Orca package here. We have the Orca zip. In our build, we've got, where am I here? In our top level build, we've got our whole plugin zip, our plugin bundle here, as well as, oops, this plugin info JSON. And does that look familiar? Yes, it should. It's the data that we put into our example repository, our plugin repository. So it has the ID, description, provider, and information about this release in particular. Cool. So we have built it with release bundle. Now let's use this plugin in Orca. So how do we do that? This is a good question. So in our PF4J stage plugin page, in the README, we've got a pretty nice debugging section down here. And I will say you do kind of have to follow the instructions like most things. And this is probably some piece that it might be nice to improve in the future if we can. Would love to hear ideas on doing this. Again, we do like to try to improve the developer experience, and that will be changing as we move to new build strategy. Anyways, let's do what it says. So we're going to copy well, I'm going to go into the random weight Orca section. Let's go to build, and let's copy the plugin ref file to, this is in random Orca here. So we're going to copy it to Orca, but not actually Orca. We want to create a top-level plugins directory within our Orca project. So let's move our plugin ref into the plugins directory and take a look at what that looks like. Again, this is a newly checked out Orca, and I created this plugins directory and added the random weight plugin ref here. Cool. Now what I have to do is go and link our plugin project here in Orca. So the way you do that is by using this plus button here, link Gradle project. I think there's other ways of doing it, but this is the way we're going to do it today. This is where my plugin lives. Spinnaker plugin examples, PF4J stage plugin, and I'm going to open the build.gradle file. It is going to take a sec to build and do all that fun stuff. So in the meantime, let's take a look at something that might be a fun plugin example. And I did not have a link to it. Okay, so if we go to get Spinnaker issues, there are a bunch of issues on here. This would be a cool place to look for feature requests or functionality requests that could be turned into plugins. So I saw someone the other day talking about a fail stage. Fail stage. And I wish I kept the link. Oh, add fail stage, here it is. So this is something that user wants. He wants a stage that all it does is it fails. So this could be a really kind of a fun and useful, at least to Ghost Squad, as well as there's actually kind of a lot of people who are wanting this functionality, right? So this could be a fun gardening day plugin to build that all it does is a stage that fails. And then, you can come in and comment on this issue and be like, hey, check out this plugin I made. You don't have to upgrade your Spinnaker or do anything, and now you have this new feature. Cool. So back over here, we've got PF4J stage added now to my Orca installation. Cool. So what we're going to do here is within Orca, we do need to tell Orca that the plugin is configured, and it needs to be used. So I'm going to copy over some configs from P4J stage plugin. And I'm going to add these to the Orca web package, the Orca YAML here. All right. And we're going to run the code. So let's go to our main function. Oops, and run it. But before we successfully run this, project main was not found. Oh, that's kind of interesting. Why is main not found? There we go. Oh, no, well, all right, well. Let's see. I feel like I'm missing something obvious there. Let's just try running this way. Oh, no, sorry. We do need to use run via main because we have a VM option to set. So there is this -d development. All right, well, we have these VM options that we want to set. And before launch, we need to add the build project task. Let's try doing this. And this does not seem right to me. All right, well, let's find out. Interesting. Well, luckily for all of you guys and for myself, I have an Orca instance, another repo open where I do have this configured appropriately. Is the working directory wrong in this one? I don't know. I don't want to spend too much time on that, but what we can see here are my configs. So I've got Orca running main. We've added this option to do development mode for plugins. And we've added the build project here. So when we run this, and in Orca YAML, oh, we do not have the plugins defined. But that's okay because it's in the plugins repo here, execution launcher. Oh, geez. Oh, sorry, this is set up right now for doing the telepresence stuff. So we'll move on to there, but you can see as the service started up, it is in development mode. So what that means is it knows to look at the configured plugins directory and load whatever is there. So you can see it's starting the plugin, the random weight plugin, and we have our log message there. So if we wanted to, on the left side here, you can see I have the P4J stage plugin loaded in. If we open up our Orca portion, and check out our random weight plugin and put a breakpoint right here. Let's try running this. I am surprised to see all the red. But check it out. Here we are in our plugin code, and we've got a breakpoint. So that's great. We can now debug into our plugin and see exactly what's going on when running locally. Now, if you want to test out certain functionality via the UI, how do you go about doing that? Right. So what we're going to be going over next is hooking this up with your running Spinnaker installation in Kubernetes. So I'm going to stop this right now. And the error, by the way, that I was seeing is it doesn't know where my Redis is, and that's because my Redis is right now it's pointing to my Kubernetes cluster. So let's take a look at that. We've done this, we've imported into Orca, and we've debugged into the plugin. So for the very last thing we're doing today is let's add our telepresence environment. Cool. So without actually, oh, here's a question here. So to install a plugin, you would put a package with your plugin into a folder. And is that all that's required to make Orca recognize your plugin? This is a good question. So installing a plugin, you can, there's a few different, this is kind of a layered question, let's say. So if you're doing development, you would want to do what we're doing here. This way you can build your plugin and debug into it. You could, instead of importing your project to Gradle here, you could have this plugins directory and just drop that zip in there. The zip that was created, the top level zip. And you'd be off to the races. You would not be able to debug into it though. And that might be helpful sometimes. So I think that answers that question. So what we're going to do next is we're going to do telepresence. So let's do that. The command we're going to run today, we're specifying the kubeconfig file. We're saying telepresence, my namespace, and we're swapping the deployment. We're doing the Orca deployment. And we're specifying a particular end file. We're actually, this was working for me yesterday. I didn't get the end file working for myself today, but that's where the spin Redis issue is coming in. So this is, we'll see it work. This is an interesting thing. Recently, I've been dealing with, what's it called? iTerm2. I don't really know this password manager thing, to be honest. What the heck? And now it works. All right. So you can see here my instances, my services are not services, just Orca. Orca has been replaced from its let's say Spinnaker operator managed instance to its own it's the telepresence instance. So what's happened is, let's make this full screen. There's now this env telepresence directory, file. And there's what has happened is telepresence has created a file system on my local host. So in this temp directory, this is quite literally the file system from our Orca instance container. Great. So that's there. Now, what we have to do is in my .spinnaker folder. Let's make this a bit bigger. I have some files from before, so I'm going to just remove them. Orca local, Orca YAML, and Spinnaker YAML. Cool. And I'm going to copy from my Orca file system that's located here, that again I got from the env telepresence file. I'm going to copy that, the opt spinnaker config files, to my local host. Cool. So now we can see we've got orca local.yaml, and we have orca.yaml and spinnaker.yaml. Notice this is what my Orca was trying to connect to earlier. Cool. So, oops. Now let's, oh, there's one aspect we also have to change. We need to specify that this is where our plugin directory is. Because remember, when Orca starts up, it will look at a certain directory, and based on what is present there, it will download plugins to that directory as well as load whatever is there. So we need to have this path and let's just grab the absolute path to the directory, and let's update our Orca local.yaml. We need to add in a plugins root path and specify where that file is. I'm also going to delete the repository in the version because we're not looking to a repository to download the plugin. It's local to us, which is why we're overriding it here. Cool. So now over here in Orca, let's take a look. What we're going to be doing, actually these are the same now because I'm not using the M file anymore. So let's run. So I have, again, I'm forwarding to DAC up here, to gate here, and we have replaced our Orca instance with our local host, our local Orca instance. So Orca started up. We can see that we are in development mode still, which is pretty cool. We see that our random wait plugin started. Sorry, I ran it with and did not do debug. And okay, this has been started up. So if we go to our local host, we can now see, we should start seeing some requests come through. Yes, so now we're seeing requests come through from our Spinnaker installation to our local host. Now you're able to, if we were running this in debug mode, we'd be able to debug, we'd be able to configure this plugin and debug as needed, right? So we can come back here. Let me just do that actually. So in our random wait plugin, in our execute method, let's just put a breakpoint here, and I'm going to run it in debug mode. I think once you have this flow going down, plugin development becomes a lot nicer. All right, so we got our breakpoint here, but this is not what we want to see in the end. We want to actually like run a pipeline and see the pipeline. We want the breakpoint in our execute method. Okay, this is actually where the stage is getting wired up. So this is some lower level details here. And great, Orca started up. Let's run this stage and let's see. Check it out. We are here in our execute method in our plugin, and it's connected to a running Spinnaker installation. As you see, it's still waiting. It's now at 14 seconds, 15 seconds. As we hit continue, it then goes and will complete. It only waited 2 seconds, but that's what we wanted to see there. And it's completed. Cool. We're like right at time, so thank you guys all for joining today. I had fun. I certainly hope you guys all did as well. Please feel free to ping me on Slack or send me an email, cameron@armory.io, or yeah, I'm in the plugins channel or the SIG platform channel in open source. Other channels as well, but those are the ones I check on a regular basis. Yeah, let me know if you guys have any questions, and thanks very much for joining.
Thanks, Cameron.
Thanks everybody for joining. Here, I can go off live now. Goodbye, YouTubers. Oh no, actually, big thanks to Cameron. Anyone have anything you want to say to the YouTubers, for posterity about this workshop? What did you learn? What was awesome about it? Or a big round of applause for Cameron and team for putting it together. I'm gonna wait for a full minute while I do this.
Thank you.
Oh, we got some applause. Heck yeah. All right.
Yeah, and I would love any feedback on this session as well. Definitely would like to improve our workshops over time.
Yeah, I should set up a channel for that. Or actually, you know what? You should post your feedback in gardening training. That's the place to do it. Yeah, we don't need another channel.
I'll make
for
a note
yeah.
in that channel too.
Yeah. Post your feedback in there, and yeah. All right.
Are you going to shut down the Zoom, Roz?
Oh,
yeah, I will. I'm just trying to go off of live on YouTube. It's like frozen. The button is not working.
Because I was wondering if we could use the Zoom for more.
For your meeting?
Well, talking with the teams about their specific plugin ideas.
Yeah. So each team should have a Zoom room. Let me check and make sure that yours does. This is Team Fresh that's going to meet, right? Yeah. And like they're not password protected, so you can use that. But like you're welcome to use this too. It's up to you. Only thing about this one is I don't know if it's like available throughout the week.
Yeah, no way. Well,
this is First Avenue, so it probably is. I have no idea. So.
Oh right. Okay. Oh yeah, I see it now in our channel.
Yeah. But like you're probably well within your right to just like switch it if you want to use this one. Yeah, I'll leave it up to you. But,
okay.
Yeah.
Thanks. I'll head out now.
Okay. Bye.
Bye.
See you guys.
Bye. Can't get my Zoom to show up. Bye for real.